Hello, welcome to video 2Q. This video is about writing equations for lines. I love the diagram in this slide. This is a drawing of downtown buildings from the point of view of a helicopter. So you can see that these are the tops of the buildings here. And one reason I love this drawing is you can see all the parallel and perpendicular lines in the drawing. For instance, right here on this building, you see all the parallel lines used to draw it. And then the tops of buildings are kind of rectangular. You see perpendicular lines. You also see a lot of cool circles. This is a great geometry drawing. Anyway, let's get on with business. Here is our first problem. We want to find the slope of this line and write an equation for the line. An equation tells me the relationship between the x-coordinate and y-coordinate of every point on the line. Like maybe y equals 2x plus 1. That's the relationship between x and y. So let's see if we can find it for this line. So every time we find an equation of a line, we got to start with the slope. So since we have a graph here, we're going to find two nice points and draw a slope triangle. And you can see I went over 2, that's the run, and up 1. So slope is rise over run, which is 1/2. Now, we know that a property of lines is that no matter which 2 points are used to find the slope, I get the same thing. The slope between any 2 points is the same for a line. So we're going to use that fact. This point here is 2, 3. And I'm going to mark another point. I'm just going to call it x, y. That represents any other point in the line. And we want to find a relationship between x and y. Okay, so we know that if we have a point x, y, and this known point 2, 3, the slope has to be 1/2. So I'm going to write a formula for the slope between my point x, y, and the point 2, 3. So remember, we subtract the y-coordinates on top. We have y minus 3. And in the denominator, we subtract the x-coordinates, x minus 2. And this has to equal the slope. So actually, this is an equation that relates x and y. It has x and y in it. But we want to kind of simplify it a little bit. So I'm going to multiply both sides by the denominator here, x minus 2. So I'm going to multiply this side by x minus 2 and this side by x minus 2. Those will cancel, and I have y minus 3 equals 1/2 x minus 2. Now, we're going to actually, soon, we're going to start here. I'm going to show you how to start with an equation like this. Now we're going to keep simplifying. We're going to distribute the 1/2. So it'll be 1/2 times x, that's that, minus 1/2 times 2, which is minus 1. The only other thing I can do is add 3 to both sides to solve for y. So I'm kind of doing some algebra here. I get 1/2 x plus 2. So the goal is to write an equation for the line and then simplify it into this form. Now we should recognize this form here. This is slope-intercept form. We see that the slope is 1/2, which we knew, and we see that the y-intercept is 2, which we can observe in the graph here. So this is where we end up. We're going to usually start here and end up there. Okay, and it gives me a relationship. If you tell me x, I multiply it by 1/2 and add 2, I got the y-coordinate. In problem number 2, we have a line here with a negative slope. So let's start by finding what that slope is. So we look at 2 nice points. We can take that point and this point. And it looks like we go down 3 and over 1. So -3, 1. So the slope for this line is -3 over 1, which is -3. And we're going to use this point here. This point is 3, 5. And I'm going to consider just one more time a point like this, x, y. So any other point on the line, we want to know what has to be true about x and y in order for it to be on the line. So, well, the story is x and y and this point 3, 5 have to have slope -3. So let's write an equation for the slope. Y minus 5, that's the difference in the y-coordinates, over x minus 3, that's the run, or the difference in the x-coordinates, has to equal -3. Okay, now maybe you wrote point checkers last year, maybe, or point testers. Maybe that term is bringing back memories. We're only going to do this a little bit here. We're going to take a shortcut in a minute. So we can either cross multiply or multiply both sides by x minus 3 to cancel this denominator. And we get y minus 5 equals negative 3x minus 3. And again, this is where we're going to start in just a minute. And now we just simplify it. Y minus 5 equals negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Add 5 to both sides. So if we add 5 here and add 5 on this side of the equation, we get y by itself, which was the goal, is negative 3x plus 14. Okay, again, we're familiar with this form of the equation. We started with a point tester. This is called point slope form. We ended up in the slope intercept form. These three different types of equations are all well known. We know the slope is negative 3. This tells me that the y-intercept is 14, which kind of makes sense. It's up here on the graph. We can't quite see it. All right, now let's take a shortcut for doing this work. All right, we're going to find the equation of lines through the following points that have the given slope. So we're going to use something called point slope form here. I have it right there. I'm going to copy it here. Y minus y1 equals m times x minus x1. This is a pattern for a line. All we have to do is substitute the coordinates of a point we know is on the line and the slope of the line. So up here, we want the line to go through the point negative 5, negative 1. This negative 5 is x1. This negative 1 is y1. And the slope is m. So we just substitute in. Y minus y1 would be y minus a negative 1 equals 5 times x minus x1, x minus a negative 5. Okay, so we plugged negative 5 in here, negative 1 in there, and 5 in here. Now, when you subtract a negative number, the same as adding a positive number, so we're going to make things easier right away by changing these minus and negatives into positives. And actually, we have an equation of the line. And normally we want to solve for y, so we're going to distribute. And then I'm going to subtract 1 from both sides, so I get y equals 5x. 25 minus 1 is 24. Done. So we didn't use the point tester or checker this time. We kind of used a shortcut. Let's try this one. This is x1, y1, and this is m. So let me write the pattern. Y minus y1 equals m times x minus x1. Okay, use this whenever you know a point and a slope. So we're going to substitute in y1 is 4, so this would be y minus 4 equals m, that's the slope, times x minus x1. That'd be x minus a negative 4, the same as x plus 4, because I'm subtracting a negative. Now let's distribute. Y minus 4 equals negative 3/4 x. Negative 3/4 times 4 is negative 3. You can do that on a calculator. And I'm going to add plus 4 on both sides. So when I add plus 4 over here, that cancels. I get y equals negative 3/4 x. When I add 4 to this, I get plus 1. Okay, let's do these two. Through 4, negative 4, and slope negative 1. So this is x1, y1, that's m. Y minus y1 equals m times x minus x1. So y minus a negative 4, the same as y plus 4, equals the slope times x minus x1, x minus 4. Okay, that's pretty good. Usually we want to solve for y, so we'll just distribute. Negative 1 times negative 4 is positive 4. If I subtract 4 from both sides, I'll have just y here. And over here, 4 minus 4 is 0. I just have y equals negative 1x. Alright, last one like this. x1, y1, that's the slope. Just substitute in. Y minus y1 would be y plus 1 equals the slope times x minus x1, x minus 4. This gets to be really quick after you've done it a few times. Negative 3/4 times negative 4, you may need a calculator for that, is plus 3. If we subtract 1 from both sides, we have negative 3/4 x plus 2. Okay, now, this is totally new to you. It takes a little getting used to. I wouldn't blame you for thinking what happened. But some of you have seen this before, and this is just review. Okay, now, this is the final slide. We're going to do 4 examples. This is really our goal of this section, to write equations for lines that are parallel or perpendicular to a given line. So here, we want a line that passes through 3, negative 4. That's the point. And we want it parallel to this line. That means it has to have this slope. So I want a line that passes through this point is parallel to this line, means it passes through this point and has that slope. So now I'm going to write the slope-intercept form, sorry, the point-slope form. Y minus y1 equals mx minus x1. So I'm going to do y minus a negative 4 is plus 4 equals the slope times x minus x1, x minus 3. Okay, I'm actually going to kind of just leave it like that for now, but the point I want you to see is, what was the slope when I was doing this? This time the slope was equal to what we're given, and actually I see it should be negative 7/3, not halves, sorry. So that should be a 3. Okay, let's try this one. So through this point and parallel to that, that means we want it to have the same slope. So our line is going to have slope negative 8 also. So y minus y1 equals mx minus x1. So y minus a negative 5 is y plus 5 equals the slope, negative 8, x minus 1. Okay, let's leave it like that. Alright, this is different. I want a line that goes through 1, negative 5 and is perpendicular to this line. That means it needs to have the opposite reciprocal slope. So the opposite would mean it's negative. The reciprocal would be 10/1. So let's write the equation. Y minus y1 equals m times x minus x1 would be y plus 5 equals negative 10. X minus x1 would be x minus 1. Finished. Okay. Last one. We want a line through this point perpendicular to this line. That means it has to have opposite reciprocal slope. The opposite would make it positive. The reciprocal would be 4/1, or just 4. So y minus y1 equals mx minus x1. So y minus y1 would be y minus a negative 1, which is plus 1. So it's 4. X minus x1 would be x minus a negative 2, which is the same as plus 2. And there's our equation. So on this page, we could have solved all of them for y. We didn't. We just want to focus on, right now, just getting the starting equation correct and using the right slope. So parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. All right, time for your journal assignment. So on here, on the first two, use the point slope form. Y minus y1 equals mx minus x1 to write equations with these points passing and with those slopes. Then, for number 3, write the equation of a line through this point parallel to that line. And number 4, write an equation through this point and perpendicular to that line. Good luck.